Hey everyone, welcome back to Master J Skills. Today we are going to dive into the series of collection framework of list interface and its implementation. So let's get started. The Java list interface is a sub-interface of a collection interface which represents an ordered collections of elements. The list interface allows for elements to be accessed by their index in the list and also supports adding, removing and replacing elements at a specific position in the list. So list allows a duplicates. So have you ever needed to store a collections of elements in a specific order? The list interface in Java is designed for exactly that purpose. So the list interface allows for elements to be accessed by their index in the list and also supports adding, removing and replacing elements at a specific position in the list. With list, we can access elements by their index and perform operations like removing, adding, replacing at specific position in the list. List allows a duplicate. When we have a similar data of a two objects, we can add it in the list where list allows a duplicates. So the list interface defines several methods for working with list. Some of them are add, remove, get, set and index of. So the add method adds an element to the end of the list at a specific index if one is provided. The remove method removes an element from the list at a specific index and shift any subsequent elements to fill the gap. The get method returns the element at a specific index in the list and set the method replaces the element at a specific index with a new element. The index of method returns the index of the first occurrence of a specified element in the list. So these are completely readable, like when we want to add, then we can go for add method. When we want to remove some object, then we can go for a remove, and when we want to fetch some data, then we can go for a get method, and if we want to update some value in the list, then we can go for a set, and if we want to fetch a specific index position value, then we can go for a index of. So this is completely readable, and apart from these methods there are many other methods supported for the list interface. You can check it in the Java list docs site. So next we will see what are the implementation of a list. So list has a below concrete implementations, that is ArrayList, LinkedList and vector and stack. So the first implementation is a ArrayList implementation. ArrayList is a resizable array implementation of the list interface with constant time access to elements by index. ArrayList uses a array data structure internally to store the elements. ArrayList automatically increases its capacity as elements are added to it, so it can handle a list of any size, so grow and sync dynamically. ArrayList stores the values sequentially, but the value can be accessed dynamically because ArrayList implements a random access marker interface. ArrayList allows a duplicate values and values will be stored in the same order as inserted. ArrayList can be accessed by the iterator or list iterator. ArrayList is not thread safe, so it should not be accessed concurrently by multiple threads without synchronization. This is great for dynamic list, but an array list is also not thread safe. So we need to be careful when accessing it concurrently from multiple threads. So this is about array list, and now let's look into the linked list implementation. So the linked list is a doubly linked list implementation of the list interface with fast iteration and deletion at any position in the list. Linked list allows for efficient insertion and deletion of elements anywhere in the list, but accessing elements by index is slower than with the array list. Linked list also uses more memory than array list, since each element in the list requires an additional pointer to its previous and next elements. That is a doubly linked list. It consumes lot of memory because it has a header and tail to link to the previous and the next nodes. Linked list allows a duplicate values and values will be stored in the same order as inserted. Linked list is not thread safe as it's synchronized. Linked list elements can be accessed sequentially. The elements in the linked list can be accessed by the iterator or list iterator. So the linked list implementation is another implementation of a list interface. Unlike ArrayList, linked list is a double linked list, which means it has a pointer to both the previous and the next element in the list. This makes it efficient for adding and removing elements from anywhere in the list. However, accessing elements by index is slower with a linked list than with a array list, and it also uses a more memory due to the additional pointers. Can anyone think of a use case where the linked list might be a better choice than an array list? Please drop in the comment box. Now let's move into the vector implementation. Vector is a legacy class which is introduced in Java 1.0. Vector is a synchronized implementation of a list interface, which means it is a thread safe for access by the multiple threads. Vector is similar to ArrayList but with additional overhead of a synchronization to ensure thread safety. Since most applications do not require a thread safe list, ArrayList is generally preferred over the vector for performance reason. Vector stores values sequentially, but the values can be accessed randomly and can grow and shrink dynamically. Vectors allows duplicates, null and dissimilar values are allowed, and values will be stored in the same order as inserted. Vector also implements random access marker interface. So the vector is synchronized implementation of list interface, which means it's a thread safe. This is a great way if we need to access the list from multiple threads, but it comes at a cost performance because of the additional overhead required for a synchronized. Vector is generally slower than ArrayList as it's a synchronized. Finally, let's take a look at a stack data structure. The stack is a legacy class and it's a subclass of a vector. Stack is a legacy class and it's a subclass of a vector. The stack class in Java is implemented using an array with a pointer to the top of the stack. When we push an element into the stack, it's added to the top of the array and the pointer is incremented. When we pop an element from the stack, the element at the top of the array is removed and the pointer is decreased. Stack is synchronized. As a stack is synchronized, stack is a thread safe. So it can be accessed concurrently by multiple threads without synchronization. So a stack is a last in first out data structure, which means that last element added to the stack is the first one removed. Stack class in a Java provides some methods for adding elements to the top of the stack, that is a push, removing elements from the top of the stack, that is a pop, and inspecting the elements at the top of the stack without removing. So we will look each one of these implementation with an example for better understanding. This is completely the theoretical. So these implementation we will see later in the with an examples. Yeah, so that's it. So that's a brief overview of a Java collection framework list interface. If you have any doubts, please drop in the comment box. Thanks for watching this tutorial. I hope you found it informative and helpful. If you want to learn more about the Java collection framework, be sure to check out my playlist of a Java collection tutorial by clicking in the link in the description below. Don't forget to subscribe to my channel for more such great content. And if you found this video is helpful, please give me a thumbs up and thanks again for watching. I will see you in the next video.